Good morning and good afternoon, depending on which coast you're sitting on in the US. Welcome to today's presentation on the future of stormwater filtration. My name is Philip Taylor. I'm Hydro's product specialist in the stormwater products. I work for Hydro International. I've been in the stormwater industry for over 10 years now. And my prior work experience, I've worked in soil and water conservation, building products design and manufacture, as well as the more recent times with Hydro International with stormwater treatment systems. My contact details are shown here on the screen. If you have any questions, please feel free to email me after the presentation and I'll address your queries as best I can. If I can't answer your questions, I'll try and forward them on to people who can. After the presentation, there will be a short survey. Certificates for attendance will be sent to all attendees. If there's more than one person in the room with you listening in and you'd like certificates of attendance for those people, please email me or respond to the email address, I think, on the follow-up email that'll follow this presentation, and send us their name and contact details, and we will also send out the additional continuing education certificates. This presentation is slated for about 45 minutes. I don't think we're going to take quite that amount of time, but if we do, please hang in there. Initially, I'm just going to talk a little bit about Hydro International and who Hydro International is and what we do. Cover a little bit about treatment technologies, innovation drivers. The influence of testing and approvals is becoming a significant influencer in the development of stormwater treatment technologies. Also, the industrial permit in the US is influencing where we're going with treatment technologies in the stormwater market. Now I'm going to just cover a little bit about looking forward into the future and the summary at the end. Hydro International is a company that's based in the UK. We have an office location, well, we have two office locations in the US, one on the East Coast, one on the West Coast. We do business in about 33 countries. We have approximately 200 plus employees. And we have direct employee representation in the Middle East as well as in the South Pacific, based out of Brisbane, Australia. We've been doing business for over 40 years. In fact, the genesis of the stormwater treatment technology in terms of vortex valves and vortex technology started with Hydro's early founders in the 1960s when we developed the very first vortex separators. It's basically variations on that product that have been developed over the last few decades that we see the development of the stormwater separators and stormwater control valves and the filtration systems that we're seeing today. Now, Hydro is fortunate. We have a really good lab and lab staff in Portland, Maine. We're one of the best hydraulic labs available to a manufactured-owned company. So we can do a lot of rapid development and experimental testing in a high-quality lab and develop products, variations on products, and look at how things react to these variations. So Hydro is well placed to be an innovation leader in this respect. And we don't just do stormwater. Hydro International has a variety of industries. We work with the stormwater and wastewater industry, CSO industry. We do flood protection works, industrial stormwater. We also have a hydrometry and monitoring and data analysis division. We do water engineering, and also we have a maintenance division. That's not on the slide, but we've also got a stormwater maintenance division, which is becoming increasingly important within the stormwater industry. We do work collaboratively with other interested parties like universities, other technology companies, and also we work with and also get approval with quite a large number of different regulators and environmental agencies around the world. So when we're talking stormwater treatment, this is a very broad category of things. And it really depends on what you're targeting as to the technology that's applicable to that targeted pollutant. For instance, if I was working in on the West Coast in California, they have regulations around screening and trash removal. I think Florida does as well. That requires basically 100% removal of gross solids. So in that sort of situation, we're looking at screening technology, looking at the larger particle sizes, sort of 1 millimeter and larger, big flows generally, and gross pollutant removal. As we move along the spectrum of total suspended solids, basically, and we go to coarser solids, we're talking the fine sands up to coarse sands or very fine gravels. That's where hydrodynamic separation comes in. They're ideal for that situation. Then as we move along the spectrum, we start going down below 100 microns, down below those fine to very fine sands, and now things get a little trickier. The settling velocities of these particles are a lot slower. Some advanced vortex separators work okay in this sort of area. One of the key aspects of that is to prevent washout of previously removed sediments, because when we start getting to these finer sediments, washout becomes an increasingly important aspect of stormwater cleanup and the prevention of the resuspension and washout. This is where we also find pond design coming in. Large settling basins, underground settling basins and the like get used in this area. Then as we move down further, we start getting what we call the non-settleable solids. We're talking very fine silts into the clay range, 1 to sort of 20 micron. Really, it's now we're talking about filters. We're talking about sand filters, very large settling basins. And also we're talking now about associated pollutants that come along with that. So phosphorus, nitrogen, and metals are in this sort of range. Then as we move really down on the very fine stuff, sub 0.45 microns, we're talking about dissolved solids and microbial stuff that's really difficult to remove, and that's where technology is struggling a little bit at the moment. So why filtration? This is an interesting aspect. As we get down into that lower end of the range, costs escalate. The cost of the product escalates, the cost of maintaining the product escalates, the cost of installing the product escalates. So there's a big jump in cost as you move down to these finer particles, but the return on water quality also goes up tremendously as well. So it's a bit of a cost-benefit equation. So why filtration? Well, as we get down, removing particles less than 50 microns, the only practical solution is very large settling ponds, large settling basins, or filtration systems, maybe polymer enhanced systems using coagulants, an option as well. And also removal of dissolved pollutants like nutrients and metals. That's where we're really looking at filtration. Now, this industry has developed a lot in the last few years, and there are several developing themes within the filter market. And one of them is, in the proprietary filter markets I'm really referring to, are the cartridge style filters. And probably a lot of you have seen these, typically storm filter type things, bay filter, some of the trade names you might have heard of. These are basically cartridges that sit on the floor of a vault and act as either radial flow or similar, or flow up through the system. Some of them have media in them, some of them may be just membrane filters, but basically a cartridge system is a system that's fairly common now, easily scaled. Another type of system is basically a gravity system. These are, or a media type system. Some of these are pressurized. They're either used for isolated treatment of hotspots or industrial applications. There have been cases where these systems, the pressurized systems, are used in conjunction with large storage systems so that the stormwater is put into storage, run through a pressure system, and then released out into the environment. And we have things like the upflow filter here. This is the one that Hydro develops, which is basically a low pressure media filter type system. So these are the media filters. Then more recently, we've come across developments into what we call membrane filters. So these are basically fabric type filters. They generally don't contain any media. They're a straining system, and they use a fine membrane as a filtering system. So there's that type. And also the bioinfiltration filters now coming in. We've seen this for many years now. The tree in the box system. These are basically media filters where the water percolates through the system. The tree or the vegetation may help maintain percolation rates, but most of the treatment is done within the soil mass and the specialized soil that is used. And it's either infiltrated into the ground below that or through an under drain out to discharge. So what's driving all this? We have these different systems being developed. Companies are trying to improve on old themes, developing new themes. Well, the innovation drive is really, at the very top, it's basically regulation. Basically, regulation forces action. We don't generally react until something's got so bad that we have to. It's an unfortunate situation that clean water doesn't really get noticed, dirty water does. And that if we'd noticed the clean water first and kept it that way, we wouldn't be in this situation, but we have what we have. Also, test standards, protocols, and approvals has a tremendous influence on technology. So typically with the local water quality standards, we're talking about the Clean Water Act and additions to that, total maximum daily loads, or the 303D list, which many of you should be familiar with, which are linked to specific pollutants of concern in impaired waterways. Every local authority or every state should have a 303D list. We have the general water quality standards through the MS4 permits. These generally sort of sit around the 80% TSS reduction for sediment. We see typically numbers like 40 to 60% total phosphorus reduction being used, maybe some attempt at nitrogen removal, but they're generally a percent reduction type of regulation rather than maybe a specific effluent limit. Then we have the industrial permit. Now for us, this is an area we've been concentrating on for the last few years. The industrial stormwater permit is very strict in what it says, and it's an effluent limit, so you can't discharge more than a certain concentration of the pollutant that you're putting out. It's very specific to a site, it's specific to a pollutant, and it can change with land use, especially when you're looking at places like port authorities where, as an industrial site, what's going through the port can change on a daily or a weekly basis, which can change the pollutant concerns. So you need an adaptable system that can address all these changes. So we've got the regulation up there, over sort of an umbrella over everything. And one of the big things in our industry, especially when it comes to proprietary systems, is that there is no national clearinghouse that says I can send my equipment to it, get it tested, verified, and approved, and everyone will accept that, okay, it does what I say it does. So what we do have are two fairly large and commonly used clearinghouses. One's known as sort of Washington DOE, or Department of Ecology. Uses a thing called the TARP protocol, the Technology Assessment Protocol for Ecology. It's a test protocol and process you go through, and that's basically used primarily on the West Coast. And it's a field test verification process. So it has multiple levels of approval. So the interesting thing about approvals currently, and some of you may have realized this, or may, if you're familiar with regulations and the approval process, many regulations are written around 80% TSS or something similar to that. And in recent years, as these test protocols have been updated and brought into line with to standardize things, Washington DOE when it comes to separators, not the filters I'm talking about at the moment, they're testing for 50% TSS removal. So there's a disconnect between the TSS removal requirements between the 80% we see in many stormwater manuals and the 50% test level that we're actually seeing through the Washington DOE and New Jersey DEP. So technically, to get 80% TSS through these processes, you have to use a filter now. And the reason being that the standards, for instance, in this one here, the Washington DOE Table 2 here, to get basic level certification, general use level for basic treatment, it's basically a TSS removal standard requiring greater than 80% removal of TSS or controlled to a certain 20 milligrams per litre effluent, depending on the influent concentration. In addition, there are certifications for removal of dissolved metals and certifications for removal of phosphorus. So if I'm going to do this test protocol, really I'm looking for a filter system. Now this is expensive to do. This takes time because it's a field test. It relies on rain, so it relies on the weather to cooperate. Being a field test, it relies on the site that you're testing to cooperate. It's got to have these pollutants coming off it, and it's got to have them coming off at certain concentrations to allow you to get your test results. So this is a tremendously involved and complicated thing to do. It can take 2, 3 years, 4 years. It can involve several $100,000s of dollars. So for a vendor coming along and looking at this, you really only want to do it once. You don't want to be doing this 2 or 3 times. So you look at your filter and go, can I develop a filter that can do both the basic treatment, include the dissolved metals and the phosphorus and maybe the oil in one hit? So we're looking for a media that can do a lot of different things. So this sort of drives the shape and size and what I do to develop a filter to pass this protocol to get approval to sell the filter. Now the other major clearinghouse that's commonly used is the New Jersey Department of Environmental Protection. Now that's on the East Coast. So we've got one on the West Coast, one on the East Coast. Now this is a lab test protocol based around removing 80% TSS. Now from a vendor's point of view, this is far more specific. It's quicker to do because I'm doing it in the lab. I can control the variables. I can do it in one hit. But I'm also looking at one pollutant, and that's total suspended solids. So I'm not having to try and compromise. So now I've got a different situation with this test protocol, and this is driving a different aim in my product development. So once I go through this, I get assigned a treatment flow rate for my test unit, and I can scale that up. Now usually I just test with either a single cartridge or a single module or a single whatever it might be in my filter that represents a miniature version or a full-scale miniature that I can then just scale up. As part of this also, filters, when you design them, they've got a treatment flow rate. So there's an inflow rate that you treat and you get a result for, but as part of that, you've got to consider the overall catchment that's been serviced and the load coming off that, because you've got a load that can overwhelm a filter in one hit, as opposed to where you get a small constant flow you can treat easily, then you suddenly get a big wash and you overload the filter. So you have an exhaustion test as part of this as well, so that you might get approved to treat, I don't know, half a CFS or 0.25 CFS per module, but then at the same time you get approved that that module can only treat maybe 0.1 or 0.2 acres, so that either the area dictates or the flow rate dictates the sizing of the filter. So the influence of those two protocols is quite interesting, because when you look at it, if I go to the Washington the Washington DOE and look at what's approved there, the majority of the filters approved and being developed to pass the Washington DOE test are media filters. If I go and look at the list of approved filters for New Jersey, every one of them is a membrane filter. No media filters used at all. Now there's the reason for that, and there's also a commercial influence on that as well, because vendors are looking for an advantage to, when you do the test and you do your pre-testing, you get some idea of where you're going to be. You don't want to be on the bottom of the list because you're going to spend all this money to do the test, and you're perhaps maybe the worst performing. You're going to try and land somewhere in the middle or near the top to improve on the previously approved devices. So there's a bit of a competition in there between vendors. So why does Washington DOE favor media? Well, the answer was in this table. If I've got a single test that I want to do, or I want to put one device through this expensive and long-term test, then I'm going to want to hit as many approvals as possible with that one filter. And so when I'm dealing with TSS removal, and I'm dealing with dissolved metals, and I'm dealing with phosphorus, that's where the media filter will be the compromise system for that, because you're going to need different chemicals in your filter to be able to remove TSS. Well, that's just straight straining or filtering. You're going to need ion exchange or something like that, absorption or adsorption for copper and dissolved zinc and phosphorus. So you need a bit of a Swiss Army knife of media to be able to do all this. So you, by default, tend to use a media filter for this. When I look at New Jersey DEP, and I look at the particle size gradation of what I'm required to test at, if you look at this, you see the median particle size, the 50% finer, it's about 63 microns, something like that, 70 microns. But when I look at the weighting, a fair bit of the material, 30%, is sitting roughly around 20 microns. And 20% is below 10 microns. Now, when I get down these 10 micron sizes and below, that's the sort of stuff that'll pass through a media filter. It's so fine that it'll find its way through a media filter. To get 80% removal of this, I've got to basically try and guarantee that nothing or very little over 10 microns can pass through my filter. So the only way to do that is to put a system there that actually has a 10 micron screen in it. And that's why sort of these membrane filters are ending up on the East Coast, and media filters are ending up on the West Coast. So the test protocols are really driving the technology. So is there really any difference between media and membrane filters? Well, there is a little bit. Membrane filters, they're physical straining. They work really well for the fine TSS. You'll see that because they are a membrane filter, you really want a high surface area. So you're seeing that the technology is around trying to get the maximum surface area you can, because surface area translates directly into flow rate and load rates. And it also allows you to maybe get smaller footprints for the same flow rate. So that's where vendors in the industry at the moment are trying to work out how they can get the maximum surface area and the smallest footprint to be, say, competitive in a bidding situation, that they're not using a bigger footprint than the competitors. So the NJDEP stuff is an ongoing process of product development. Media filters, yeah, they do TSS, they do it pretty well, but they remove pollutants via adsorption and absorption. They have the potential to remove the dissolved pollutants that would pass through a simple membrane, and the potential to customize the media for changing conditions is one of the great benefits of media filters. So they have their pros and cons, and it really depends on the application. The industrial permit is a further driver of technology at this point. We started working within the industrial permit regulations several years ago, and it became apparent when we did this that people really didn't know what they're treating for, because they didn't know what was coming off their site. They know they had this permit and the regulations, so one of the first things we did was develop a piloting system where we could send a full-scale unit to a site on a truck basis, and they could pump the water through it and do some pre-testing and try and work out whether the system would work well or not, or whether it needed modification before you put it in the ground, and went to the tremendous expense, because industrial treatment is very expensive to do. This led on to sampling kits and sending out sampling systems, and actually then lab basing our pre-testing. So now we have a modeling system where we can characterize the media, and we can test different media in a rapid development process before we go to the full-scale systems. Now this has actually led to a further development within our system where we can actually use predictive algorithms now for the industrial permit based on influent concentrations to exactly what we're getting on the effluent side. And we're finding that we're getting very accurate predictive algorithms now, so we can actually take water samples, measure the concentrations that are in that, and predict what the effluent samples should be before we actually move anything to site. So this technology and our understanding of stormwater treatment is just going up in leaps and bounds at the moment. So where's the future going to take us? Big question. It's going to depend a lot on where regulation takes us. Hopefully we don't go backwards in regulation. That's anyone's guess at the moment, right? We would hopefully that regulation is moving forward, and that we do look towards water as a very valuable resource. Everyone out there in the different products, different vendors, is kind of looking for a magic media, one that's going to get high removal of nutrients, one that's going to get high removal of metals. It's going to do it at very high flow rates, at very low cost, and you never have to maintain it. That would be the utopia of stormwater filtration. I don't think we're ever going to find it. And then at some point we're going to try and remove nitrogen as well. That's another problem. So there is a lot of research going on, and we are trying to develop these high flow rate, high treatment rate, dissolved products that remove dissolved pollutants. That's where we're trying to get to. And also we're trying to develop things for industrial materials, particularly dissolved nutrients, very fine particles. Now the other thing we need to be cognizant of is that there are different climates and climate influences and what happens in those climates. You do all this work and you put your filter in the ground and you do some testing and you find that it's not working. You work out why. And one case we had, quite simply, too close to the coast. You get a big storm coming off the coast, you get a lot of chloride, salt air, salt water landing on a surface. That washes off in the next storm, and that chloride can actually act as a scrubbing process through your filters and actually cleans them. Not exactly what you want to happen. So chemical stability of your filter media against chlorides and de-icing chemicals and what else might happen on site that you never thought of when you did your lab testing and thought, hey, look, it really works. It removes a lot of phosphorus or it removes a lot of zinc. And then you throw a little bit of something else in there and suddenly all that stuff comes out the back end. You go, oh, that didn't work so smartly after all. So we have to consider the pollutant and the climate and the environment that they're going into. Also, what we find is that you'll find that products are changing rapidly now too. 3D printing is having an influence on how quickly you can prototype stuff. Technology is advancing. When we first started with the filtration system, we started with this upflow filter and a manhole configuration. Thought it'd be a great idea to make this so that it could fit inside a manhole, a standard 4-foot manhole, that it would go down through the lid, that it could be put in there and retrofitted. Turns out that a lot of the manholes that people asked about didn't suit retrofitting, that you actually have to replace the manhole anyway. Then we decided, if we zigzag these things, we could put them in vaults and make them bigger. And that was a great innovation. That worked really well. But then we thought, well, if we're going to do that, why don't we just redesign the whole module to make it square to fit in a square vault? So that's our next innovation, redesigning the whole module. And then you start thinking, Well, where does that take us in terms of innovation? If we've got a new module, can we make it a universal module, say add media one day, and should the site change or the need change, flip it and put membrane filters in there the next day, or a combination of the two. So these adaptabilities of technology is coming into it, and that's where we're heading within Hydro, is that we're looking at filters that can be adapted to a variety of conditions on the same site without actually digging anything up. That you can actually maybe add more, you can allow for future expansion by putting empty vaults in and just use them for volume control, and then later on install a modular system. Now we're getting towards the end, so only a few more minutes. BMP maintenance is perhaps the ignored BMP. This is one of the biggest problems we have in the industry, and I think this is part of the future of stormwater treatment. That's going to have the biggest influence on water quality is the maintenance of the BMPs. Even these big ponds that we see around there, big stormwater ponds, they're all going to get to a point where they're not going to be working effectively, that they're going to be full, they'll need dredging and cleaning, tremendous cost there. Hydro itself is set up, as I mentioned before, a maintenance division, so we can control, well not control, but offer these services as part of the sale, because we know that maintenance is going to be an increasingly important part of stormwater pollution removal. And structural and financial longevity. Everything we need to be has to be designed to last for a long time. And one of the important drivers of innovation now is also, what's this cost the owner on a long-term basis? It's not about the short-term X dollars to put it in. It's about what it costs every year to keep that thing running. And that's an important part of the whole innovation drivers that we're going through. So we're looking at how we can make these costs more acceptable and you know, provide a solution that engineers can offer their clients, and it's not going to break the bank to keep it maintained, because at the end of the day, it's the maintenance and the continued maintenance of the system in good working order that's going to be good for water quality, not the system as it was installed on day one. It's the system as it operates 3 years, 4 years down the line. So basically, in summary, regulation and pollutants are driving the use of filters. Test protocols, as we went over, really are dictating the type of filter being used, because we're designing filters, A, to do a job, but B, we're also designing them to pass the test protocols, because if you can't pass the test protocols, you don't have a business. So membrane filters have been basically designed for high TSS removals, high flow rates on the East Coast, and media filters basically are working out on the West Coast through the Washington DOE test protocol. And these then become available to everyone to use. Significant research is going into filter media at the moment, and also the adaptability of filters. We're seeing this amongst a number of vendors are trying to make one filter be able to do several things, or to be able to switch it out a little bit. And the final thing is maintenance. You know, maintenance is going to be a really big part of BMP performance in the future. So with that, I'd like to thank you very much for listening. I see we had about 140, 150 people online. Excellent turnout. Thank you very much. So if you have any questions, feel free to email me. My name is Philip Taylor. My email address there is ptaylor@hydro-int.com. So there will be a follow-up survey when I close this. There will also be an email coming out, and everyone will get their attendance certificates. And if you need more, just email us and we'll get those to you. Thank you very much. Have a good afternoon.